Welcome. In this video, I'm going to be working all of the Unit 2 quizzes for CalBC this year. And so we'll start with quiz 2.1, and this is just over our elementary derivative rules, mostly power rule, a little bit of trig derivatives, e to x, log x, stuff like that. And okay, so the first one is give an interpretation of h of 5 equals 3 and h prime of 5 equals 2. Okay, and h represents the temperature of the room. Okay, so since h represents the temperature, I'm going to say, okay, h of 5 equals 3 means at time 5 minutes, the temperature is 3 degrees. (3°C). Okay, and then h prime of 5 equals 2 means the rate of change of temperature with respect to time at t equals 5 is going to be 2. Which means that at t equals 5, the temperature is increasing 2 degrees per minute. (2°C per minute, right? Units of the output divided by units of the input. Number 2 is, all right, this is just a power rule question with a graph attached. So first up, in order to find a prime of negative 2, we're going to need to find a prime of x. So I'm going to say, all right, a prime of x is going to equal, okay, well, I need to rewrite this first. That's going to be 2x to the negative 3. If I do the power rule on 2x to the negative 3, I'm going to get negative 6 times x to the subtract 1, that would be minus 4. And then the derivative of 3f of x is going to be 3f prime of x. And then I'll plug in x equals negative 2. And so f prime of negative 2. And then I need to go over here to negative 2. Say, what's the slope here? I think it's going from here to there. That's going to be a slope of 1/3. Okay, so I've got negative 6 times negative 2 to the negative 4th. Okay, and we're best to just leave that way. Okay, not turning it into a fraction, and just leave it the way it is, right? It's a number, it's good enough. 3 times f prime we determined was positive 1/3, and that'll be enough for us. Okay. Number 3, this is another power rule question, this time with a table attached. And so b is f of x divided by 2 plus the 4th root of x, which I'm going to rewrite as x to the 1/4. Okay, start with b prime of x, take the derivative, and then we'll plug in 3. Right. So b prime of x is going to be half of f prime of x, because we could rewrite this as 1/2 f of x. And we could take the derivative of it the same way we took the derivative of 3f of x right there. All right, so b prime of x is going to be 1/2 of f prime plus, and then I'm going to use the power rule over here, 1/4 of x to the negative 3/4 when I subtract 1. Okay, now I'm going to plug in x equals 3. And 1/2 f prime of 3 is going to be 1/2 of negative 2. And then 1/4 of 3 to the negative 3/4. Okay, and that's just a number, so I'm going to be happy and stop there. And the next one's asking us for an equation for a tangent line. So we're going to need a point. Okay, the point is x equals pi over 6. And y is going to equal 1 minus 6 pi, sine of pi over 6. Okay, so I'm going to draw the triangle. Pi over 6 is pretty down low over here. It's kind of like the first stop, so I'm going to draw it like that. We know this is 30, 60, 90 because the pi over 6s and pi over 3s are always 30, 60, 90s. And on the unit circle, the hypotenuse is always 1, the short leg of a 30, 60, 90 is a half, and the long leg is root 3 over 2. I'm going to take a second to check and make sure everything has the correct sign. Yeah, these should both be positive because we're in the first quadrant. And now I can say, all right, sine of pi over 6 is opposite over hypotenuse, that's a half. Okay, so 1 minus 6 times a half. Okay, so that would be 1 minus 3, that's pi over 6 and negative 2. Then the slope, I'm going to need to take the derivative. And so if I've got y, then the derivative would be dy dx is 0 minus 6 cosine x. Okay, to get the slope at the point I'm interested in, I'm going to just plug in x equals pi over 6. And I'm going to get negative 6 times the cosine of pi over 6. Cosine of pi over 6 is going to be adjacent over hypotenuse, so that's root 3 over 2. And so I'm ready to write my equation. So y minus negative 2 is equal to the slope, which is going to be negative 3 root 3, times x minus the x coordinate of the point we know is on the line, so it's x minus pi over 6. Okay. Yeah. Now, we're on to the back. More power, so just take the derivative, that's dy dx. So that's going to be 5x to the 4, and the derivative of e to the x is e to the x, so that'll be 5x to the 4 plus 5e to the x. Over here, this next one, here we need to decode this. This thing here, limit of rise over run as run goes towards 0, with x going towards 2, that's code for g prime of 2. Okay, so we need to be able to recognize that and know that that means, hey, take the derivative and plug in 2. So g prime of x is going to equal derivative of 3x is 3, derivative of log x is 1 over x. And then I'm going to plug in 2. And that's going to be 3 plus 1/2. And that's good, that's a number. All right, finding the values of a and b that would make f differentiable at all x. That's going to be where we need to set the pieces equal to each other to make sure it's continuous, and then we'll take the derivative of each piece, and make sure that they're equal so that it's not only meeting up, but meeting up smoothly. So to make sure it's continuous, we're going to say x plus a equals bx to the third at x equals negative 1. Okay, I'll plug in x equals negative 1, but that's not going to, I mean, it's just going to give me an equation in a and b. So negative 1 plus a equals b times negative 1 to the third. And yeah, and so that's negative 1 plus a equals negative b. Okay. So in order to make sure that it's going to be continuous and differentiable, I'm going to take the derivatives of each piece and set them equal to each other. Derivative of x is 1, a is a constant, its derivative is 0. And then 3 times b times x to the 2. Okay. At the point where x equals negative 1. Okay, so I start to plug in. It's like, oh, okay, I see at 1 equals 3 times b times y squared negative 1 is equal to 1. So that means b is 1/3. And then I can go over there using that, and I can say negative 1 plus a equals negative 1/3. Okay, so I might just add 1 to both sides. And negative 1/3 plus 3/3, that's going to be 2/3. And so I'll say a is 2/3, and then I'll just clearly display my answer there. And if you're wondering, like, why didn't it say it was continuous and differentiable for all x? That would be because if they say differentiable, then that means it must also be continuous. That was something that we've learned in this unit, is that if a function is differentiable at a point, then it must be continuous there as well. So they don't need to say it if they just say differentiable. All right, now we're going to find the value of k so that the line tangent to the graph of g at x equals 1 is parallel to the line that contains. Okay. So that means the slope of the tangent line at x equals negative 1, which we know that's g prime of negative 1. The slope of that line is the same as the slope of this line. So I'm going to say, all right, y2 minus y1 divided by x2 minus x1. So I've got negative 4 over 4 is going to be negative 1. Okay. But then I can also get a formula for g prime of negative 1 by taking the derivative of g and using the power rule. So g prime of x equals 3x squared plus 2 times k times x. And if I plug in negative 1, I'd get, okay, 3 plus 2k times negative 1, so maybe I call that 3 minus 2k. Negative 2 minus 2, 3 minus negative 1. Okay, I just wanted to double check that. I don't remember getting that the first time, but it's been at least a week since I worked this one. And okay, so now I know that 3 minus 2k equals negative 1. I'm going to subtract 3 from both sides. Divide by negative 2, and I'll see how k equals 2. And then the last one, we want to find the values of x where this thing has a horizontal tangent. Okay, horizontal tangent, that's where we're going to take the derivative, and we're going to set it equal to 0. Okay, so we can take the derivative. 6x to the 2 minus 6x to the 1 minus 12. And we want to set that equal to 0. Okay, if we want to find where this is equal to 0, we're going to need to factor. I mean, we could use the quadratic formula, but I'm telling you that's not the way to go. We're going to say I'm going to factor out the 6. I'm going to look at the thing in the box, and I'm going to say, oh, I can factor that a little more. And I'm going to say that 6 times x minus 2 times x plus 1 is equal to 0. And now that I've got this list of things multiplied together to equal 0, I know that one of them has to equal 0, right? That's the only way I can get 0 is with things multiplied together is one of them's equaling 0. So either 6 equals 0, which is not sounding likely to me, or x minus 2 is equal to 0, or maybe x plus 1 is equal to 0. And these are our x locations of horizontal tangents. Okay, so that was I. 2.1 form J. Okay, now we're talking about pieces of candy operated by a factory, or produced by a factory since it opened, and that's going to be C. Okay. C is measured in number of candies, and T is measured in hours. Okay, so C of 2 is 250, and C prime of 2 is 200. All right, so at T equals 2 hours, okay, the number of pieces produced is 250. Okay, so I would say factory has produced 250 pieces of candy. I think pieces will do. And then C prime of 2 equals 200 means that the rate of change of the number of pieces of candy that they have made at the factory that day at T equals 2 is 200. So if that isn't ringing a bell to you, then you would go to the units and say, okay, what's going to be the units of the rate of change? It's going to be the units of C, pieces of candy, divided by units of T, hours, candies per hour. That's how fast they're producing candy. Okay, so at T equals 2 hours, the factory is producing 200 pieces per hour. Okay. All right, now we've got a power rule with a graph. Okay, so first we're going to find a prime of x, and then we're going to plug in x equals 2. And we'll be able to do that. Okay, first I'm going to need to rewrite this as a negative power of x, so that'll be 3x to the negative 2. And so if I do the power rule to this, I'm going to multiply the negative 2 by 3, and I'll get negative 6. X to the subtract 1, that'll be negative 3. And I'll take the derivative of 4f of x, and I'll get 4f prime of x. Right. Then I'm going to plug in x equals 2. So it'd be negative 6 times 2 to the negative 3rd plus 4 times f prime of 2. And then I go over here to x equals 2. And I say, okay, what's the slope here? That's looking like negative 2. Okay, so I'll say that's negative 6 times 2 to the negative 3rd plus 4 times negative 2. And that's a number, so that's going to be a safe place to stop. Let's move on. Okay, we've got a table and another power rule situation. I feel like this feels very similar to the one I did in Form I. I might not have changed this one. So I'm going to rewrite this as x to the 1/4 power. And I'm also going to rewrite this as half of f of x, because I noticed there were some people that were concerned about, the denominator, wanting to take the derivative of the denominator and saying it didn't exist because you were dividing by 0. That's not how that works, right? It's just 1/2 f of x, so the derivative will be 1/2 of f prime. With constant multiple, we don't have to worry about the product rule. Hopefully you've come around on that. But if you haven't, keep working. And if you're not seeing what I'm talking about, come talk to me and I'll show you. Okay, b prime of x, okay, it's going to start with half of f prime. and then it's going to be plus 1/4 of x to the negative 3/4. Okay? When I plug in 3, I'm going to have half of f prime of 3, which is something I can look up in the table, plus 1/4 of 3 to the negative 3/4. Okay, so over here, half of f prime, so it'd be half of negative 1 plus 1/4 of 3 to the negative 3 divided by 4. And that's going to number, so that'll be a good place to stop. Okay, now we're going to write the equation for the tangent line to the graph of 1 plus 8 cosine x at x equals pi over 3. Okay, so we need a point. X will be pi over 3, and y will be 1 plus 8 times the cosine of pi over 3. Okay, we're going to need to draw a diagram, I think. And pi over 3 is pretty high up there. It's pretty close to pi over 2. And so we know that this is going to be a 30, 60, 90 triangle because it's pi over 3 or pi over 6. We know on the unit circle the hypotenuse is always 1, and on a 30, 60, 90 triangle the short leg is a half and the long leg is √3 over 2. I always recommend you take a second to make sure you're in the right, you have the right signs, because of the quadrant you're in, where x is positive and y is positive, so these would both be positive. And cosine is going to be a half. So that's 1 plus 8 times a half, that's going to be 5. Then the slope, I'm going to need to take the derivative, so the derivative of y is equal to 0 minus 8 sine x. All right, and then when I actually plug in x equals pi over 3, I'm going to have negative 8 times opposite over hypotenuse, √3 over 2, so that'll be negative 4 square root 3. And so then I can write the equation, and it'll be y minus the y coordinate is equal to the slope multiplied by x minus the x coordinate. All right, and number 5, we're going to just take the derivative using the power rule, so 6x to the 5, and then I guess we just need to know what the derivative of log x is. That's 1 over x. Okay, that's a fact that if you don't know it yet, yeah, get to knowing it. Okay, this next one, this is code for g prime of 2. Okay, this is the limit of rise over run, so this is the slope of g, and as x is approaching 2, well, that means we're going to plug in x equals 2. So I'm going to take g prime of x, and the derivative of 4x is 4. And the derivative of 4e to the x is, well, the derivative of e to the x is e to the x, so it's just going to be 4e to the x. And then I'll plug in x equals 2. And I'll be happy. Let's move on. All right, we're going to find the values of a and b that make f differentiable for all x. And if a function is differentiable, then it also has to be continuous. Okay, and I already did work this one once. This is identical to the one on Form I, so if you already saw me do that, you're not going to see anything different. But we need to set these two pieces equal to each other so that the function is continuous. And then we're going to, plug in x equals negative 1. And then we need to make sure that it's differentiable, so we're going to take the derivative of each piece, 1, and 3bx squared, and we're going to set them equal to each other so it meets up not at a sharp corner, but smoothly. And then I'm going to also need to plug in x equals negative 1 there. So I'll have 1 equals, okay, when I square negative 1, I get positive 1, so 1 equals 3b. I divide by 3, and I get b equaling 1/3. Okay. Then negative 1 plus a equals negative 1/3. And I'm going to solve for a by adding 1 to both sides. Okay, so if I have 1 minus 1/3, that would be 2/3. And so I see that a is going to need to equal 2/3, and b is going to need to equal 1/3. All right, the next one is going to be, okay, find the value of k so that the tangent line to g at x equals negative 1 is parallel to the line that contains these 2 points. Okay, so the slope of the tangent line to g at x equals negative 1, that's g prime of 1. And the slope of the tangent line is going to be the same as the slope of the line that goes through these points, so if it's the same, it's going to be equal. And I'm going to just run the slope formula on this, negative 6 minus 2. Divided by 3 minus negative 1. And so that's going to be negative 8 divided by 4 is negative 2. Okay, Now I'm going to find g prime of 1 the old-fashioned way, right? Taking the derivative. And then I'm going to set these two things equal to each other and hopefully be able to solve for k. So g prime of 1 is 3x squared plus 2 times k times x to the first. And then I'm going to say, oh, okay, wait, but that's g prime of x. Okay, I'm not quite there yet. G prime of 1, so what's going to happen when I plug in x equals 1 to g prime of x? So that's going to be 3 times 1 is 3 plus 2k. Okay, so I'm going to take g prime of 1 is equal to this, g prime of 1 is also equal to that, so these two things must be equal to each other. Okay, I think I will subtract 3 from both sides. Divide by 2, and get k is negative 5/2. Okay. Now, if we're going to find the values where this thing has a horizontal tangent, we're going to need to take the derivative of it and set it equal to 0, right? Because horizontal tangent means the slope of the tangent line is 0, and the slope of the tangent line is the derivative, so I'm going to set the derivative equal to 0 and solve for x. So I will take the derivative of f using the power rule. Minus 0, right? Because the derivative of 5 is 0. I saw a couple of errors on that when I was flipping through the quizzes after they'd been graded. And we're going to need to set this equal to 0. And if this is a polynomial set equal to 0, the next step is to factor, right? And so I see a 6 common to all of these, and so that might make my life a little easier. X squared plus x minus 2. And then, okay, yeah, I can factor the things in the square brackets. That would be x plus 2 times x minus 1. Yeah. And since I've got these three things that are all multiplied together to equal 0, one of them has to be equal to 0, right? So either 6 is equal to 0, which that's not going to happen, x plus 2 is equal to 0, or x minus 1 is equal to 0. And so these are the x locations of my horizontal tangent. And that is all for quiz 2.1. All right, so quiz 2.2, this was about the product and quotient rules. And the first one is just what's the slope of the tangent line at the point where x equals 1. So we're going to take the derivative and plug in 1. Okay, this is a fraction, so I'm going to need to use the quotient rule, right? And it starts off with bottom, so it's bottom times the derivative of the top minus the top times the derivative of the bottom divided by the bottom squared. Okay, and then f prime of 1 is equal to, all right, when I plug in 1, I'm going to get 2 times 3 minus 1 plus 3 would be 4 times 4 divided by 2 squared is going to be 4. Okay, I'm going to recommend you actually simplify this one. I've got my reasons. And that's going to be 6 minus 16 is negative 10 divided by 4. I think that's far enough that we could recognize the right answer choice in a multiple choice scenario, if you know what I'm saying. So that's going to be enough for that one. Okay. H is going to be f times g in this next one. They've given us a graph of f and a graph of g, and they want to know, is h prime of 1 going to be positive, is it going to be negative, or is it going to be 0? And we're going to show the work that leads to our answer. So first, we're going to need to find h prime of x before we plug in x equals 1, right? So we're going to need to just kind of like regurgitate the product rule, take the derivative of 1 while leaving the other one the same. And then I'll add taking the derivative of the other one while leaving the 1 the same. Okay. And then I'm going to plug in 1. And that's going to be of 1, g of 1 plus g prime of 1 times f of 1. Okay, in each of these four things, we're only going to be able to determine whether they're positive or negative or 0. Okay, so f prime of 1 is going to be the slope of f at x equals 1. That is a negative number. G of 1 is also a negative number. It's just the height of the graph. It's down here below the x-axis, so that's also negative. Then I'll add in g prime of 1. That's a positive number because the slope is positive through there. Multiplied by f of 1, also a positive number because the height of the graph is positive or the graph is above the x-axis. And if I've got a positive plus a positive, well then that means that h prime of 1 is positive. Right, over here we've got 2x squared multiplied by cosine x, and we want to take the derivative of that. So we've got these two things multiplied together, they both have x's, and then we need to use the product rule. So I'm going to say, I'm going to take the derivative of 1 first. I'll take the derivative of 2x squared while leaving cosine x the same. Then I'll add in, leaving 2x squared the same, taking the derivative of cosine x, which is going to be negative sine x. Okay. And you could call that minus 2x squared sine x if you wanted, but you don't need to. Okay, now we've got a table problem with a quotient. Okay, so we're going to need to use the quotient rule. So k prime of x is bottom times derivative of top minus top times derivative of bottom divided by bottom squared. Okay. Then when I plug in 3, I'm just going to need to look up all these values from the table. So f is 2, g prime is negative 1, minus g is 5, and f prime is negative 2, divided by f squared. Okay. And so this would be negative 2 plus 10 is going to be 8, divided by 4, that's 2. Okay, that might be another one that you're best off simplifying to help you recognize the correct answer choice in a multiple choice scenario. Right on the back side. All right, so this next one, we've got h is x times f of x. And so we're going to eventually need to take the derivative of h, I know, because it's the product and quotient rule quiz, so I'm just going to jump in and do that right now. I know that we need the equation for a tangent line, so I'll need an actual value of h as well. But so h prime of x is going to be, I take the derivative of x as 1, leave f the same. Then I'll leave x the same and take the derivative of f. Okay, so I've got h prime of x. In order to get an equation for a tangent line, I'm going to need a point and a slope. So my point I'll get from taking h of 4, and that'll be 4 times f of 4, which would be, f of 4 is 1. Okay. So h of 4 equals 4. The slope is going to be h prime of 4 equals f of 4 plus 4 times f prime of 4. So f of 4 is going to be 1 plus 4 times the slope of f at x equals 4. This is a line segment. It looks like the slope is 1, 2, 3, 4. Yeah. Okay, so that's looking like h prime of 4 is going to be 17. And then the equation is going to be y minus the y coordinate, which is h of 4, is equal to the slope times x minus the x coordinate, which they said was x equals 4. Now I've got an equation for my tangent line there. All right. We're going to heat water in a cylindrical container for time between 0.5 and 5 minutes. At time t equals 0.5, the temperature of the water 12. I don't think that's really relevant to what we're doing here. I think that's for later on when I'm going to ask you some other questions about the fact that it's a cylinder. As the water is heated, the temperature of the water increases at the rate of g of t degrees Fahrenheit per minute. Find g prime of 1. Okay, well, that's going to be easy enough. We're just going to act like this has no context and just take the derivative of g. It starts with bottom times the derivative of the top. Now, the derivative of the top is going to be 40 times the derivative of log t with respect to t, so that's 40 times 1 over t. I might just call that 40 over t. Minus the top times the derivative of the bottom. Well, the derivative of the bottom is just going to be 1. Divided by the bottom squared. So g prime of 1 is going to be, okay, when I plug in 1 here, I'm just going to get 40. Minus 40 log of 1. Oh, okay, 40 log of 1, I need you to know what that is. It's the special exponent you put on e to get 1. So that's going to be 0. So 40 times 0 would be 0. 40 minus 0 divided by 1 squared, that's just going to be 40. Okay. And then using correct units, we're going to explain the meaning of g prime of 1 in the context of the problem. All right, so g prime is it's going to be the rate of change of something, right, because the derivative. Rate of change of, and then I'm going to insert language for g that I get from the statement of the question, and I'm going to say at time t equals 1 minute, I think. Yeah, minutes. Okay, now we're going to go back to the statement of the question. What is the meaning of G? Okay, G is going to be the rate of water temperature increase. Okay. Now we're going to need units, so that's going to be units of G. G is degrees Fahrenheit per minute. So degrees Fahrenheit per minute divided by units of T is minutes. Okay. With the ones where it's the rate of change of a rate, you don't get too caught up in it. Remember that the derivative is the rate of change of whatever the function represents, and then copy in the language from the statement of the question. This one wasn't actually written as clearly as a lot of the College Board ones are, where you can just actually copy it word for word. Okay. Now these last two, we're going to write the derivative of the function, and I know that if y is secant x, dy dx is secant x times tangent x. Okay, but if you didn't remember that, you would need to use the quotient rule for that, right? And then I know that the derivative of cotangent is, dy dx, is negative cosecant squared x. Okay, that's formula.
Can you explain the tangent rule?
Just a second.
Thank you.
All right, so the slope of the tangent line, that means we need to take the derivative, and we're going to plug in x equals 1. So we're going to use the quotient rule for this. We're going to say, all right, the derivative of f, it starts with bottom, so it's bottom times derivative of top minus top times the derivative of bottom divided by bottom squared. Okay, then we're going to plug in x equals 1. We're going to get 2 here, 4 there, minus 4 here, and 3 there, divided by 2 squared, and that's going to be 4. Okay. Now, on the quiz, you hopefully legislate like this. But I'm going to recommend that, you at least occasionally think about simplifying one of these, because, what if we saw a multiple choice question like this? Okay, so I'd have 8 minus 12 is negative 4 divided by 4. That's negative 1. Okay, we can do that. Some of these we can do. We need to be able to do them, right? And so, this next one, we're going to look at these graphs and determine whether h prime of 4 is positive or negative or 0. Okay, so we're going to start by taking the derivative using the product rule. So that's f prime of x multiplied by g of x, and then I'll take the derivative of g and leave f the same. Okay, then I'll plug in 4. And so that'll be f prime of 4 times g of 4 plus g prime of 4 multiplied by f of 4. And I can look at the graphs and determine whether each of these things is positive or negative or 0 individually. So at x equals 4, I'm going to actually mark that off. 1, 2, 3, 2, 3, 4. Yeah, okay. That's x equals 4 right there, and I might as well do that for g as well, because 4 is far enough away that I could be fooled. All right, so f prime is the slope of f. That's going to be positive. It's going up. G of 4 is a negative number because it's below the x-axis. And then g prime of 4, it looks like it's close to 0. I'm not sure, but I think it's probably 0. It doesn't matter because f of 4 is definitely going to be 0, right? It's there. You can see it's equal to 0. Okay, so I've got a negative number plus 0, and I can prime of 4 is negative. Okay. Then the next one. Have y equaling 3x to the 3 multiplied by sine x, and we're going to take the derivative of y. And we can do that. So y prime, we're going to take the derivative of 3x to the 3 while leaving sine x the same. And then I will leave 3x to the 3 the same and take the derivative of sine x. All right. And yeah, that's good enough. Right, now we're going to apply the quotient rule, and we're going to, after we apply the quotient rule, just plug in x equals 3, pull the values from the table, and get ourselves an answer. Okay, so remember the quotient rule starts with bottom, so it's bottom times the derivative of the top minus the top times the derivative of the bottom divided by the bottom squared. Okay. And then I'm going to say, all right, well, k prime of 3 is going to equal f of 3 times g prime of 3 minus g of 3 times f prime of 3 divided by f of 3 squared. Okay, so I've got 10 minus 2 is 8 over 25. I wouldn't want anybody to, you might need to simplify one like this in a multiple choice scenario coming up soon, so just be aware of that. All right, on to the back side. All right, this is speeding up a little, I think. H is equal to x times f of x. We're going to write an equation for the line tangent to the graph of h at x equals 2. Okay, well, I know eventually I'm going to have to take the derivative, so I'm going to do that right now. I'm going to say h prime of x. I'll take the derivative of x. That's 1, and leave f of x the same. Then I will leave x the same and take the derivative of f, and that'll be h prime of x. Now I'm going to need a point and a slope to write an equation of my tangent line, right? So my point I'm going to get from plugging in the x value, h of 2 equals 2 times f of 2. I'm going to go over here to the graph and look and see, oh, okay, f of 2 is negative 1. So 2 times negative 1 is negative 2. Then the slope would be h prime of 2 equals, and I'm going to plug in over here, so it would be f of 2 plus 2f prime of 2. Okay, that's looking to me like, okay, f of 2 we determined was negative 1. And then f prime of 2 is, that's going to be negative 2 because it went over 1 down 2. Okay, so negative 1 plus negative 4, that's going to be negative 5. Yep, that's still visible. Okay, now that I've got a point and a slope, I'm ready to write my equation. And I'm going to use point slope form, and I'm going to say y minus the y coordinate, so y minus negative 2 is equal to the slope times x minus the x coordinate of the point we know is on the line. Okay, that's good. Okay, now this one, oh, this one's slightly different from form I, but even if it was exactly the same, I still work it a second time in case you just skip straight to this form. So g prime of 1, to get g prime of 1, I'm going to take g prime of t, and then I'm going to plug in t equals 1. All right, so I'm going to take the derivative of g. And it's going to start with bottom, so it's bottom times derivative of the top. And the derivative of 30 log t is going to be 30 times the derivative of log t with respect to t. So it would be 30 times 1 over t, which is going to be the same as 30 over t, minus the top times the derivative of the bottom divided by the bottom squared. And then I'll plug in t equals 1. And that's going to equal, well, if I plug in 1 here and there, I'm just going to have 30. Minus 30 log of 1, all divided by 1 squared. Okay. Now in this class, I need you to evaluate log of 1, because 1 is a power of e, and we're called to evaluate unit circle trig, logs of powers of e, and e to logs. Okay? And so you think 1, what power of e is that? That's e to the 0, so the log of 1 is 0. And I'm going to have 30 minus 0 divided by 1, so that's just going to be 30. All right. Now, explaining the meaning of g prime of 1 in the context of the... pardon me, I lost myself. I paused to talk to somebody, and I don't remember what I was saying. But we're going to explain the meaning of g prime of 1. So it's a derivative, so it's a rate of change of something. And then I'm going to insert language in a second. At time t equals 1 minute, I think, yeah. All right, now I'm going to go and I'm going to steal the language from the statement of the question, right? It's the rate of change of whatever g represents. Okay, g is the rate of water temperature increasing, the rate the water temperature increases at. Okay, the rate of change of the rate at which the water temperature increases. Don't forget the units. The units of the derivative are the units of the output, so the units of G, which it looks like degrees Fahrenheit per minute. Per unit of input, and the unit input was T in minutes, so in degrees Fahrenheit per minute, okay, at time T equals 1 minute. Right, and now we're going to write the derivative of the function. Okay, we know that the derivative of tangent x with respect to x is secant squared x. But we also know that if we can't remember that in the moment, we're going to recover it using the quotient rule and maybe a trig identity or something. Then over here, cosecant, again, you could use the quotient rule if you wanted, but I'm kind of in a hurry. I'm going to say I know that that's negative cosecant x times cotangent x. And that's all for quiz 2.2. All right, now we can move on to the chain rule, quiz 2.3. And so they're showing us the graph of f. Looks like I'm getting really good mileage out of this graph. G is going to equal 3x minus 5. H is f of g of x. What's the value of h prime of 3? Okay. So if I'm taking the derivative of h, on the outside I've got f, and on the inside I've got g, which I've actually got a formula for, so I'm going to do that. Then outside prime is going to be f prime. Inside prime is going to be 3. And then the derivative, h prime of x, that's going to equal the product of outside prime and inside prime. So it's f prime of something multiplied by 3. And whatever goes inside these parentheses is the same as what went inside originally. So that's going to be just g of x. Or you could put 3x minus 5. Doesn't matter. Same thing, right? Because g of x is 3x minus 5. And so if I want to find the value of h prime of 3, I'm going to need to take the value of f prime of, well, what's g of 3? We can do that off to the side. G of 3 is 3 times 3 minus 5, which is 4. So it's going to be f prime of 4 multiplied by 3. That's a copy error. Yeah, I need to copy prime. Okay, f prime of 4 is the slope of the graph here, and it's over 1 up 4. So it's 4 times 3 is going to be 12. Number 2. F of x equals e to the x over 5. I always recommend throwing a little parentheses around whatever is inside the exponential to remind you that this is an outside and inside situation, and we'll need to use the chain rule. So if I'm going to write f in terms of outside and inside, my outside is e to the whatever, and my inside is x divided by 5. Which I might say is the same as 1/5 of x, because I know y'all are going to more dependably take the derivative of this than the derivative of that. Okay, eventually you'll be fine, right? But first, we're really at the very outset of our journey of taking derivatives together, and so like at the beginning, it's probably good that we write it as 1/5 x. Okay, I'm going to take the derivative of outside, e to the thing is its own derivative. Inside prime is just going to be 1/5. And then to get f prime, I'm going to multiply outside prime by inside prime. And then whatever goes in here is what went in there originally, so that's x divided by 5. Okay. Now to write a tangent line, I'm going to need a point and a slope. So I'm going to get the point by plugging in x equals 5 log 2. No, I've already got the point. That was kind of them. But I know this problem, there's an equivalent multiple choice question that's very similar to this. They just give you the coordinates, the point. Okay. And so to get the slope, I'm going to need f prime of 5 times the log of 2. Okay, well, whatever, we can work with that. E to the, well, if I take 5 log 2 and divide by 5, well, that's e to the log 2. And we know what that is. That's just going to be 2. And that's multiplied by 1/5. And the reason why that's 2 is, think about this. Log of 2 is the special exponent that we put on e to get 2. So if I put that special exponent on e, I'm going to get 2. And so I'll have 2 times a fifth is 2/5. And now that I've got a point and a slope, I'm ready to write my equation. So it's going to be y minus the y coordinate is equal to the slope times x minus the x coordinate. Okay. Now, number 3. Okay, this has got 3 layers of chain. Okay, so we're going to need outside, middle, and inside. And this was kind of like an experimental quiz question that I decided to roll out this year because I felt like we had been actually succeeding on the chain rule at a much higher rate than in previous years. So I was like, let's see what they've got. And y'all did pretty good on this one. So I'm going to just say on the outside, I've got the square root. But we don't like to write square root, right? We like to write thing to the half power. Then on the middle, I've got the sine. Okay, so that's just happening there. And then inside is going to be x squared plus 3x. You can't see that, but there I've written it. Okay, then I'm going to take the derivative of all of these things. 1/2 of the thing to the negative 1/2. Middle prime is going to be equal to cosine of whatever. And then inside prime is 2x plus 3. Okay. And just like how I had to multiply outside prime by inside prime, now I'm going to have to multiply outside prime by middle prime by inside prime. Just multiply them all together. Okay, so dy dx is going to equal 1/2 of whatever to the negative 1/2. That probably wasn't enough room, but times cosine of whatever times 2x plus 3. And just remember to be judicious with your parentheses, because if I'm lacking the parentheses, this is going to mean something different, right? It's going to multiply all of this and then add 3 after the fact, and then you would be wrong. And that would be unfortunate, right? I don't want that. So we're going to leave the inside of the square root the same. This is going to be tough to fit. Then the inside of cosine, and that's x squared plus 3x. And then, okay, we're good. dy dx, 3 layers. All right, now we've got some table problems, and I'm going to say, all right, k prime of x is going to be, I'll take the derivative of the outside, that's going to be g prime, while leaving the inside the same, and then multiplying by the derivative of the inside, which is going to be 3. Leaving the inside the same. Decided not to do the o's and the i's on this one. Okay, k prime of 1 is going to be g prime of 3 times 1 multiplied by 3, and then I look up g prime of 3 in the table, that's 4. Wait, no, g prime of 3 is 2 times 3. This is going to be 6. All right. And then if m of x is f of x taken to the 3rd power, what's going to be m prime of 2? Well, I'm going to label my outside is that thing cubed, and the inside is f. Okay, we're going to take the derivative of outside, and that'll be 3 times that thing to the 2. And inside prime is f prime. Okay, so m prime of x is going to be 3 times something squared times f prime of x. And in the inside, it's whatever went inside the cube originally, that's f of x. Okay, now I'm going to look all this stuff up off the table, and I'm going to get m prime of 2 is equal to 3 times f of 2 squared. So f of 2 is 9. Multiplied by f prime of 2, which is going to be 2. So 6 times 81, that's the type of thing, 46, maybe best staying here, right? Best off staying here. All right, now we got 2 more on this form. I've only got 2 minutes. I don't think that's going to happen. Oh well, I'll have to record more of this at lunch then. F of x is going to be e to the sine x. Find f prime of pi over 3, and all right, so on the outside, I've got e to the thing. Okay, and on the inside, I've got sine x. Okay, so outside prime, the derivative of e to a thing is going to be e to that thing. And inside prime is going to be cosine x. And to get f prime, I'm going to multiply outside prime by inside prime. And whatever goes in here is what went in there originally. That's going to be sine x. All right, f prime of pi over 3, I'm going to need a trig diagram. So I'm going to go up here to pi over 3. That's pretty high up there. And it's going to be a 30, 60, 90. We know in the unit circle the hypotenuse is always 1. On a 30, 60, 90 triangle, the short leg is a half, and the long leg is root 3 over 2. And so if I need sine of pi over 3, that's going to be opposite over hypotenuse, root 3 over 2. Multiplied by cosine x, adjacent over hypotenuse, that's times 1/2. That's going to be f prime of pi over 3. Okay. All right, now I've got one more And this is log of x taken to the second power. So on the outside, I've got the square, and on the inside, I've got log x. Okay, outside prime is 2 times that thing to the first. Inside prime is 1 over x. Okay, that means that dy dx, the first derivative, is going to be 2 times log x to the first multiplied by 1 over x. And now to take the second derivative, you can use the product rule on this. I'm going to take the product rule and I'm going to take the derivative of 2 log x while leaving 1 over x the same. Then I'll add in, leaving 2 log x the same. The derivative of 1, well, that's like x to the negative 1, so that would be times negative x to the negative 2. That was the most dependable way to solve this one that I saw. You could also do 2 log x divided by x and use the quotient rule. And that was what I did the first time I worked this problem. But I saw more people getting it right using product rules, so that's probably what I would suggest you do. Maybe I'll use quotient rule on the other form. All right, now we'll do form J. So let f of x, or h be f of g of x, and g is 3x minus 5. Okay. So if I'm going to take the derivative of h, I'm going to have to find my outside and my inside. On the outside, I've got f. And on the inside, I've got g. But I've got a formula for g, so maybe I'll just write that right down there. And so I can take my derivative of my outside and my inside. And the derivative of the inside, well, that's just going to be 3 minus 0. Okay. And so h prime of x is going to be outside prime multiplied by inside prime. Okay, and what goes on the inside of these parentheses is the same that went on the inside originally. That's g of x. And I might even say 3x minus 5. Because we've got a formula for g. And then from there, I'm going to say h prime of 0 equals f prime of 0 minus 5 multiplied by 3. I can go over here to negative 5 and say, okay, I can find the slope of this line. That's going to be 1/3, it looks like. Okay, and then I'll be happy with that. All right, f of x equals e to the x over 4. We've got a point already there. We want a tangent line, so we need a point and a slope, right? So we've got the point ready. We just need the slope. And to get that, we need f prime of x. Okay. Over here, the outside is e to the thing, and the inside is equal to x divided by 4. But I might write that as 1/4 x, because y'all are more dependable at taking the derivative of this than you are of x divided by 4. Okay, I'll take the derivative of outside. The derivative of e to the thing is e to the thing, and the derivative of the inside is 1/4. Okay, so I'm going to get f prime by multiplying these two derivatives together. And then multiplied by 1/4. Yeah, that's good. Yeah, that's good right there. Thank you. Yeah, just a second. Pardon me. Okay. So I'm going to replace this with whatever went in there in the first place, and that's x over 4. And if you have trouble recognizing exponentials as chain rule things, slap some parentheses around the exponent, right? Just to remind yourself when you see that. Okay, so now I'm going to say f prime of 4 log 3 is going to be e to the, well, if I take 4 log 3 and divide by 4, it's going to be e to the log 3 times 1/4. And, well, that's going to be 3. Because the log of 3, that's the special exponent I put on e to get 3. So if I put that special exponent on e, I'm going to get 3. And so that's going to be 3 times 1/4 is 3/4. And now I've got a point, I've got a slope, I'm ready to write my equation. So y minus the y coordinate is equal to the slope times x minus the x coordinate. Here, this one's got 3 layers, so I'm going to do outside, middle, and inside. Okay, the middle is the square root, but I don't like square. I'm going to write it as something to the half power. And the inside is going to be 3x squared plus 5x. You can take the derivative of all 3 of these things. Inside prime is going to be 6x plus 5. Right. That means that dy dx is going to be the product of all three of these derivatives. And remember to always be judicious about your parentheses, right? We need those parentheses around the 6x plus 5. Okay, what goes inside the cosine is what originally went inside the sine, which was a square root of 3x squared plus 5x. And then in here, what went inside the square root originally? 3x squared plus 5x. And there I've got myself a formula for f prime, or dy dx, or whatever they're calling it. Okay, if k of x equals g of 2x, what's the value of k prime of 2? Show the Orthodox finance. Okay, we can do that. I'm going to say that k prime of x, we will take the derivative of the outside while leaving the inside the same, and then multiply by the derivative of the inside for the chain rule. So times 2, leave the inside the same. Okay. And then I'm going to say, oh, just k prime of 2. Okay. That's easy enough. G prime of 4 multiplied by 2. Look up G prime of 4 from the table. That's 7 times 2. That's going to be 14. Okay. Over here, we've got a more of an outside and inside, so maybe I'll do those in the eyes on this one. On the outside, I've got that third power. On the inside, I've got f of x. Okay, and I'll take the derivative inside and I'll get f prime. Okay, m prime of x is going to be 3 times that thing squared times f prime of x. And what goes inside the box is what went inside the box originally, that's f of x. Okay, m prime of 3 is going to be 3 times f of 3 squared times f prime of 3. Okay, so I'm going to look up f of 3 and f prime of 3. So f of 3 is 10 and f prime is negative 4. So I've got 300, because 10 squared is 100, times negative 4 is going to equal negative 1200. And we just got 2 more. So we're going to take the derivative of this thing. On the outside, I've got the exponential. And on the inside, I've got cosine x. So I'm going to take the derivatives of outside and inside. Right. F prime of x equals e to the whatever times negative sine x. Okay. So what I'm going to need is eventually plug in x equals pi over 3. So I'm going to need to make a trig diagram. Okay, pi over 3, pretty close to pi over 2. So I'm going to draw it. It's very tall. And we know on the unit circle the hypotenuse is always 1. And on 30, 60, 90 triangle, the short leg is a half, and the long leg is root 3 over 2. Okay, so that means that cosine adjacent over hypotenuse, that's a half. Times negative sine is going to be negative root 3 over 2. And then the last one is going to be if y is log of x taken to the second power, find the second derivative of y with respect to x. Okay, so if the outside is this thing squared, then outside prime is 2 times that thing to the first, and inside prime is 1 over x. And I just lost my, I was zoned out. Dy dx, the first derivative, that's going to be 2 times something to the first times 1 over x. And whatever goes in here is what went in there originally. That's log x. Okay, and so that's a good expression for dy dx. I'm going to write this as 2 log x divided by x so that I can use the quotient rule when I take the second derivative. Now, if I did took the second derivative using the product rule in form I, and that should be, I don't know, somewhere around like 50 minutes in this video, maybe about 9 minutes ago. Something like that. That could be where you could see me taking the derivative of this using the product rule. It's equivalent, it looks kind of different, but most people actually in my class that were solving this correctly were using the product rule. But in case you use the quotient rule, I need to show you that too. Bottom times the derivative of the top minus the top times the derivative of the bottom divided by bottom squared. Okay, and that's, I'll just walk away, that's the second derivative right there. Okay. Now, quiz 2.4. This one should go a little faster. All right. Now, I don't usually do this, but I think on this one, I'm going to use the same formula so many times that I need to remind you that f inverse prime is 1 over f prime of f inverse, where f inverse is just some x value. Okay. Now, if f is equal to 4 plus 3x plus 2 sine of x, so if g is the inverse function for f, then we're going to find g prime of 4. All right, so we can use our formula here. So we really want g prime of 4. That's equal to f inverse prime of 4, which is 1 over f prime of f inverse of 4. F inverse of 4 is going to x value of 0. So this is going to be 1 over f prime of 0. Now I'm going to have to take the derivative the old way. The derivative of 4 is 0. The derivative of 3x is going to be 3. And the derivative of 2 sine x is going to be 2 cosine x. F prime of 0 is going to be 3 plus 2 times the cosine of 0, which we know is 1. And so that's 5, and so this is 1/5. All right. And pardon me, I'm recording this during class. Probably not the best idea, but I'm just really trying to get this published as soon as possible. So we're going to find the slope of the line tangent to f inverse at the point where x equals 4. All right, so we want the slope of the tangent line. That's the derivative, right? So 4, that's equal to 1 over f prime of f inverse of 4. And then I will say, all right, f inverse of 4, I go here, say f of x equals 4, that's x equals 1. Okay. And f prime of 1 is looking like 2 to me. Yeah, it's got a slope of 2. So this is 1 over 2. Yeah, you're good. Then over here, g of x is x to the 3 plus 2, and we want g inverse of 1, so we say g of x equals 1. We say x to the 3 plus 2 equals 1. We're just going to start solving. And then we say, hey, x is negative 1. Okay, so g inverse of 1 is negative 1. Okay, so g inverse prime of 1 is going to be 1 over g prime of g inverse of 1. And g inverse of 1 we just found was negative 1. Okay. G prime of x equals 3x to the 2. Oh, there's something off about this problem. I think I needed to make it, oh, then it would have been harder to solve. That's the issue, yeah, because the squared things. You can be right for the wrong reason. Hate that, but it's all right. So g prime of negative 1 is going to be 3. And so this is 1/3. Okay, yeah, you can just put it on, I've got a stack. Oh, I've got it. Thank you. All right. And then the last one for this form is, okay, we've got h is a function with h of g equals g of h, which is equal to x for all x. That means g and h are inverses of each other. And so we want h prime of 1, that's a g inverse prime of 1. And we've got a formula for that. That's 1 over g prime of g inverse. But I guess we haven't figured out what g inverse of 1 is yet. Okay. G inverse of 1 we'll compute by setting g of x equals 1. We'll go back to x, that's x equals 0. And so it's going to be 1 over g prime of 0, which is over there. That's 1 over -3. That's form I. All right, form J, last quiz, last form. So let f of x be 5 plus 4x plus 3 sine x. We know f of 0 is 5, and we know g is the inverse function for f, and we want g prime of 5. So we're going to say g prime of x, or g prime of 5 is f inverse prime of 5. And we've got a formula for that. That's 1 over f prime of f inverse of 5. Okay, well, we can see here that f inverse of 5 is 0. And that's going to be 1 over f prime of 0. F prime of 0, well, we're going to have to find that the old way, right? So we're going to just take the derivative by hand. That's going to be 4 plus 3 cosine x. And then f prime of 0 is going to be 4 plus 3 times the cosine of 0, which I know is 1. And so that's 7. And I've got 1 over 7. And oh yeah, and then that's it, right? That's all we needed was the value of g prime. Okay, now we're going to find the slope of the tangent line to f inverse at the point where x equals 6. Okay, so we want slope of the tangent line, that's the derivative of f inverse. Okay, and we want to plug in 6. So we've got a formula for that. 1 over f prime of f inverse of 6. Okay, to find f inverse of 6, I'm going to say f of x equals 6. So I go up to y equals 6. Oh, hey, look, I found it. It's right there. That's x equals 0. Okay, so really what we have now is 1 over f prime of 0. The slope of this graph at x equals 0 looks like it's -½, so 1 over -½ That's an option you have. Say that's -2. Right, g inverse of 10. Okay, well, if we want g inverse of 10, we set g of x equals 10, and we solve for x. So x to the third plus 2 equals 10, subtract 2. That looks like x to the third equals 8. Okay, that means that x has to equal 2. Okay, and that's g inverse of 10 is equal to 2. Find the value of g inverse prime at 10. Okay, we'll say that's equal to 1 over g prime of g inverse of 10, which fortunately we just computed to be 2. Over. Oh, okay, so when I made a bad choice on form I, it was just the x, or really the input value that was bad, because this is, you wouldn't be right for the wrong reason on this one. Oh, that's kind of unfair. Too bad. Oh well. 1 over g prime of 2. So I just got to figure out what g prime of x is. G prime of x, I probably should have made it -6 on the other form, so it was -2 in that. No. Oh, we've been the same for both forms. I don't want that to happen either. Okay, g prime of x is 3x squared. And meaning g prime of 2 is going to be 3 times 4, which is 12. So this is 1 divided by 12. The last one is the most common type, right? We've got some coded language that basically means h and g are inverses of each other. And we want to know what the value of h prime of 0 is. So we've got, we want h prime of 0. We know h is g inverse. And we've got a formula for this, 1 over g prime of g inverse of 0. Okay, now to find g inverse of 0, we're going to set g of x equals 0. We're going to find it. There it is. That's x equals 1. And that's going to be 1 over -6. All right, that was all 4 quizzes, Form I and Form J, all the way through. I hope this helped. And if you need any other, if you have any other follow-up questions to that, you can leave it in the comments, or you can come talk to me in person. But really, thanks for watching.